There is something that relativistic physics implies that almost no one dares to say out loud. Not because it is too difficult to understand, but because once you truly understand it, it changes something fundamental about the way you think about your own life and what happens when it ends. Einstein's equations do not describe the universe as something that happens in time. They describe it as a structure that exists in time, in the same way a sculpture exists in space. The past has not disappeared. The future has not yet arrived. Those phrases make intuitive sense, but they have no correspondence with what relativity describes. In the geometry of space-time that Einstein formalized, all moments of the universe, every instant of everything that has happened, and every instant of everything that will happen, coexist as parts of a single four-dimensional structure. Physicists call this the block universe. And what it implies about death is something Penrose has explored with the same precision with which he explores the singularities of black holes or the paradoxes of quantum mechanics. Not as a consolation, as a logical consequence of geometry. Your death, if the block universe is the correct description of reality, is not the moment you cease to exist. It is the point where your world line ends. And a line that ends at a point does not cease to exist at previous points. The moments you lived do not disappear when you die. They remain in the coordinates where they occurred, as real as the moment you are in right now. But before this sounds like a comforting metaphor, the argument must be built from its foundations. Because the block universe is not a philosophical idea that one accepts or rejects by preference. It is the direct consequence of one of the most verified results of 20th century physics, the relativity of simultaneity. In 1905, Albert Einstein published his theory of special relativity. The most disconcerting result of that theory was not that the speed of light was constant for all observers, although that was disturbing enough. It was that simultaneity, the question of whether two events occur at the same time, has no universal answer. Two observers moving at different speeds relative to each other cannot agree on whether two events occurred simultaneously, not because one of them is measuring incorrectly, but because there is no objective fact about simultaneity that is independent of the observer's state of motion. This has a consequence that philosopher Hilary Putnam formalized in 1967 in a paper that remains one of the most cited in the philosophy of time. If there is no objective simultaneity, then there can be no objective and universal present. Each observer has their own slice of space-time that they call the present. And if each of those slices is equally valid, then the past and the future of one observer are simultaneous with the present of another. What for you is still the future, for someone moving fast enough relative to you, has already happened. Penrose often pauses at this point with a precision that his students described as disturbing. Not disturbing because it is obscure, but because it is exact. He explains that there is a way to visualize the relativity of simultaneity that makes the block universe cease to be abstract and become almost tactile. Imagine you are standing on a train platform and see a high-speed train pass by. In the center of the car, a light bulb turns on. You, from the platform, see the light reach the front and back of the car simultaneously. For the passenger inside the car, the light also reaches the front and back at the same time, but that time is not the same time you are measuring. Your clocks are not synchronized, not because his clocks are defective, but because time itself flows differently for objects in relative motion. Einstein proved this with mathematical precision that admits no escape. And its most radical consequence is not that clocks run differently. It is that the very structure of space-time has a shape that depends on the observer. There is no layer of universal present extending throughout the cosmos at the same time. There are infinite possible layers, one for every possible state of motion, and all are equally valid. The block universe is not a hypothesis we add on top of relativity. It is contained within it, with the same necessity that the Pythagorean theorem is contained within the axioms of Euclid. And this is where the argument reaches its most uncomfortable point. If the future of one observer is already the present or the past of another, then the future exists, not as a possibility, as a region of space-time that is already there with the same ontological reality as the past. The block universe is not a poetic interpretation of relativity. It is its direct logical consequence, and it is very difficult to escape it without abandoning relativity itself. Penrose knows this difficulty better than anyone. He has spent decades working on the border between general relativity and quantum mechanics, and he knows that the block universe faces serious problems when attempting to reconcile it with the probabilistic nature of quantum mechanics and the irreversibility introduced by the second law of thermodynamics. But he also knows that ignoring the implications of relativity on the nature of time would be intellectually dishonest. The geometry of space-time is real. The relativity of simultaneity is real. And its consequences regarding the permanence of past events are real. This is not a philosophy of consolation. It is geometry. And geometry is not negotiable. It was looking for answers to this that I found this digital book. The Penrose Dossier, What Academia Fears to Admit, is not a book about death or immortality. It is a tool for a specific kind of thinking. Thinking that does not stop at the reassuring answer, that does not file away the uncomfortable question as resolved, when in reality it has only been avoided. Penrose has spent decades sustaining questions that most of his colleagues would prefer not to ask. The nature of time, the reality of the block space-time, what physics implies about consciousness and about what we are. This book documents that posture, not the result, but the disposition of someone who does not accept that an equation is a sufficient answer when the question is what it means to live in a universe described by that equation. You are in that state right now. The mind active, something that seemed obvious beginning to be seen differently. There is a brief window between the moment an idea disturbs your model of the world and the moment you normalize it and move on. It is in that window that real change occurs. The link is in the first pinned comment. But beware, this content may be taken down. Click now. Download your copy. Does knowing that, in the geometry of space-time, this present will always have existed change anything about how you live it? Leave your answer in the comments. To understand exactly what the block universe implies, one must first understand what a world line is. In relativistic physics, every object, every particle, every person, every star traces a path through space-time. Not just through space, but through space-time as a unit. That path is called a world line. It is the complete history of that object, where it was at every moment, what speed it had, how it interacted with other things. Your world line began at the moment of your birth, in the spatial and temporal coordinates where that event occurred. Since then, it has traced a continuous path through space-time that records every position you have occupied at every instant. The moment you learned to walk, the first day you saw the ocean, this instant, right now. All those events are points on your world line, and in the block universe, all those points exist simultaneously in the structure of space-time. Your death will be a point where your world line ends. But in the block universe, A line that ends does not disappear. The preceding points continue to exist at their coordinates. The past is not erased. There is no mechanism in relativistic geometry that eliminates past events. What we call the past is simply the region of space-time that is on one side of your current position on your world line, and that region is as real as any other. Penrose uses a precise image for this. Think of a sculpture. A sculpture exists in space. It has a left side and a right side, a top and a bottom. When you look at the right side, the left side does not disappear. It continues to exist in its spatial coordinates with the same reality as what you're looking at. Now add time as a dimension. The block universe is a sculpture in 4 dimensions. Your life is a region of that sculpture. When your life ends, the events that compose it are not erased. They continue to occupy their coordinates in the 4-dimensional space-time sculpture. This has implications that go beyond abstract comfort. They have to do with the question of what identity fundamentally is. If your life is a geometric structure in space-time, then what you are is not just the present instant. What you are is the totality of that structure. The child you were in your early years is not a previous and vanished version of you. It is a region of your world line that exists with the same reality as the adult you are now. The person who will die, the point where your line ends, will not cancel any of the preceding points. It cannot. Geometry doesn't work that way. The physicist Hermann Weyl, a contemporary of Einstein and one of the most important mathematicians of the 20th century, expressed this with a clarity that is rarely cited outside of physics departments. He wrote, "The objective world simply is. It does not happen. Only to the gaze of my consciousness, crawling upward along my world line, does the world come to life, as a spatial image continuously changing in time." That sentence, written in 1949, captures something Penrose considers fundamental: the difference between the universe as experienced by consciousness, which perceives a flow from past to future, and the universe as described by geometry, which has no preference for any temporal direction or for any moment over another. The link is in the first pinned comment. The last units are running out. Click now and start your journey towards the clarity and genius you deserve. But here, the argument becomes more subtle. Because the block universe seems to imply absolute determinism. If all moments already exist in the structure of space-time, then the future is already there, fixed, immutable. Every decision you will make, every word you will say, every moment of your life you have not yet lived already exists in the coordinates where it will occur. And that directly conflicts with the subjective experience of free will and with the probabilistic nature of quantum mechanics. There is an objection that always appears at this point, and it deserves to be answered carefully. The objection is this: if all moments exist simultaneously in space-time, then free will is an illusion. Everything is already determined. The decisions we believe we make freely are already written in the geometry of the universe. Penrose's answer to this objection is not reassuring in the ordinary sense. It is more honest than that. Penrose distinguishes between 2 questions that are frequently confused: whether the future exists as a region of space-time, and whether the future is determined by the present. They are different questions. The first, as we have seen, has a clear relativistic answer. Yes, in the block universe, the future is a region that exists. But the second involves quantum mechanics, the intrinsic indeterminacy of subatomic processes, and the question of whether quantum collapse, which is genuinely random in most interpretations, leaves room for a form of real indeterminism. Penrose does not resolve this tension because, honestly, it cannot be resolved yet. What he points out is that even in a block universe with quantum indeterminism, the permanence of past events is preserved. What happened, happened, and that region of space-time does not change retroactively depending on what the future decides. The past, in the block universe, has a solidity that the future, perhaps, does not. And that asymmetry between the absolute permanence of the past and the relative openness of the future is, in itself, a profoundly interesting structure. Penrose takes this tension seriously, more seriously than most, because it is exactly in this tension where Einstein's block universe and quantum mechanics contradict each other most obviously. Quantum mechanics is irreducibly probabilistic, at least in the standard interpretations. The future is not determined by the present with absolute certainty. There are quantum processes that are genuinely indeterministic, and if those processes are real, then the future cannot already exist with all its details fixed in the structure of space-time. Penrose's response is not to choose one of the two frameworks and discard the other. It is to point out that both are incomplete and that their reconciliation requires a physics that does not yet exist. A physics that explains how Einstein's geometric space-time and quantum randomness coexist in a coherent description of reality. That physics, when it arrives, will probably modify our understanding of what time is and what the permanence of past events means. But what it will not modify is the central result of relativity, that past events are not erased. That the reality of the past, in any future theory consistent with relativity, will have to be preserved. There is something profound in this asymmetry. The future may be uncertain, the past is not. Quantum mechanics introduces uncertainty about what will happen. But once something has happened, once an event has taken place in space-time, its reality is complete and irrevocable. There is no known physical mechanism to erase past events. What happened, happened. And in the geometry of space-time, what happened remains in the coordinates where it occurred, regardless of what happens next. Penrose finds something in this that is neither religious nor sentimental, but neither is it cold. It is simply precise. Every act of understanding you had, every moment of genuine connection with another person, every instant when the universe seemed coherent and beautiful to you, those events will not disappear when you die. They already occurred. They are in space-time, and space-time has no recycling bin. The link is in the first pinned comment. The last units are running out. Click now and start your journey towards the clarity and genius you deserve. There is a thought experiment Penrose has used in different contexts to illustrate what it means for time to be a dimension and not a flow. Consider a novel. A novel exists as a physical object in space. It has pages. It has a beginning and an end. And all its pages exist simultaneously. When you read page 40, page 100 has not disappeared. It is there in its spatial coordinates within the book. The character in the novel, who on page 40 still does not know what will happen to him on page 100, does not alter that fact. Page 100 exists while he remains ignorant of its contents. The block universe works in an analogous way with time. All moments exist simultaneously in the structure of space-time, in the same way all pages of a novel exist simultaneously in the physical object of the book. Consciousness, which perceives time as a flow from past to future, is like the reader moving through the pages one by one. But the existence of the pages does not depend on the reader having read them. They exist independently of the reader's experience. What this implies about death is precise. Death is the moment the reader stops advancing through the pages. But the pages you already read do not disappear when the reader closes the book. They remain where they were. in the coordinates where they always were. Now, I need to speak to you directly, because there is a reason this idea produces a very specific response in those who listen carefully. Not exactly relief, something more akin to responsibility. If the events of your life are permanent in the geometry of space-time, if what you do today does not disappear but is inscribed in the coordinates where it occurred, then the question of what to do with the time you have acquires a different weight. Not the weight of the fear of being judged, the weight of real irreversibility. Every moment you live becomes, in the instant it occurs, something permanent, not a memory that can be distorted or lost. Into an event that exists in space-time with the same reality as anything else that has occurred in the history of the universe. That permanence does not distinguish between the moments we consider important and those we consider trivial. They all remain. The instant you chose to listen to these words exists now in space-time. The moment you decided to do something you still regret also exists. And the moment you did something genuinely worthwhile also exists and will continue to exist. Does that change anything about how you inhabit the present? Not the abstract answer, the concrete answer. Penrose is not a philosopher of practical life, and I do not intend to be one here. But there is something honest in pointing out that the physics describing the permanence of the past has implications for how you live the present that go beyond metaphysical comfort. There is a distinction worth making precisely, because it is the distinction on which the argument can fail if not made correctly. The permanence of events in space-time is not the same as the persistence of consciousness after death. They are completely different claims. The first is a consequence of relativistic geometry. The second would require a completely different physics that we currently do not have. Penrose does not argue that consciousness survives the death of the brain. There is no physical basis for that claim. What is in the equations, however, is that the events in which that consciousness participated do not disappear. This distinction is important because it turns the argument into something verifiable and honest, instead of consolatory and vague. It is not about you continuing to exist after you die in any experiential sense. It is about the fact that what you lived, in a precise geometric sense, will always have existed. The life you had will not be erased. The events that compose it will remain in their coordinates in space-time, regardless of whether there is anyone to remember them. That is different from immortality in any religious or spiritual sense, and it is more modest. But it is also, in a way, more solid, because it does not depend on any hypothesis about consciousness or about what happens after death. It depends only on the geometry of space-time, which is the most well-verified structure in all of physics. There is something Penrose points out in this context that deserves special attention. The question of what existed before the Big Bang, which in standard cosmology is dismissed as ill-formulated because time itself began with the Big Bang and it makes no sense to ask what came before time, has a direct analog in the question of what comes after death. If time is a dimension of space-time and not an independently flowing entity, then after death and before the Big Bang have the same logical structure. They are questions that assume the existence of a time external to space-time, which has no correspondence with the physics we know. Time is not the stage on which events occur. It is one of the dimensions in which those events exist. And that means the question of what is there after your world line ends is not of the same kind as the question of what is there after a city ends when you reach its limits. There is no after external to space-time waiting. There are coordinates within space-time where your world line exists, and coordinates where it does not exist. And that is all physics can honestly say. That may seem less than you expected, or it may seem exactly enough. Penrose, who has lost colleagues and friends over decades of work in theoretical physics, never spoke of these ideas as a consolation. He presented them as consequences. And there is a dignity in that approach that I find more honest than any promise of continuation. What you are is a structure in space-time, a complex, improbable structure exceedingly brief on a cosmic scale, capable of asking questions about the universe that contains it. That structure has a beginning and an end in the temporal dimension, but in the geometry of space-time, having a beginning and an end is not the same as being ephemeral. A sculpture that exists in a finite volume of space is no less real than one that occupies all of space. A life that exists in a finite interval of time is no less real than one that existed forever. Death does not erase. It bounds. And in the physics of space-time, bounding is not the same as destroying. So keep this final image. In the space-time coordinates where every moment of your life occurred, that moment exists, not as a memory, not as a possibility, as a real event in the geometry of the universe. The block universe does not promise continuation. It promises something different and, in its own way, more precise: permanence. Everything you lived is already part of the structure of the universe. And the structure of the universe, as far as physics can tell, is not erased. That is not everything we would want to know, but it is what the equations say. And there is an honesty in sticking to what the equations say rather than going further than geometry allows, which Penrose has always considered the correct stance before a question that truly matters. The universe owes nothing to our intuitions about permanence or our fears about disappearance. It works the way it works. And it turns out that the way it works carries something remarkable within it. Moments do not disappear. That in a universe that had no obligation to be that way is extraordinary enough.